Let us continue with some theorems. Theorem, this is called as consistency laws. Okay, consistency laws. Let L less than or equal to be a lattice. Then for every A and B in L, subdivision A is A or B is equal to B if and only if A less than or equal to B. Then subdivision B, A and B is equal to A if and only if A less than or equal to B. So here you see the first case A or B can be taken as A plus circle B. Okay. Instead of or you can take plus circle. Instead of and you can take star. So anyway we are going to consider the first case and we are going to continue with the proof. Okay. Now proof A. Proof for A or B is equal to B. Suppose that we are assuming A or B is equal to B and we are going to prove A less than or equal to B. So we know less than or equal to, if and only if means we have to assume the first case and we prove the second case. Then we assume the second case and we prove the first case. Since, so here we have assumed, okay, suppose A or B equal to B. Just now we learned A is less than or equal to, okay, just now we learned A will be, what is that? We learned the meaning of A or B, right? A or B implies A will be less than or equal to A or B. B will be less than or equal to A or B. So here A less than or equal to, okay. So here, let me write that A is less than or equal to, so this is less than or equal to, A is less than or equal to A or B. And this implies A less than or equal to B. Okay, A less than or equal to A or B. So we can write A less than or equal to B. Therefore, we have A less than or equal to B. That is the first case. That's all is the first case. We have proved it. Okay, A is less than or equal to A or B by definition. That means A less than or equal to A. Otherwise, A less than or equal to B. So I have taken A less than or equal to B. And therefore, we have A less than or equal to B. That is the proof here. Now, conversely, we have to assume the second part and we have to prove the first case. So, second part is A less than or equal to B. Let us prove A or B is equal to B. So, then, so now assuming A less than or equal to A less than or equal to B, then B is less than or equal to B. Okay, this is known. This is our assumption. That means B is always equal to B. So we can write B less than or equal to, it satisfies equal to condition. B less than or equal to B. B is an upper bound of A and B. Why do we call B as an upper bound? Because A is less than or equal to B. Also B is less than or equal to B. So B is greater. In both the case B is greater. So we say B is upper bound of A and B. That means A or B is least upper bound of A and B. So B is upper bound of A and B. A or B is least upper bound of A and B. Just now we learned, right? We learned A or B is the least upper bound of, you say B is upper bound, okay? B is upper bound, but A or B is least upper bound. So A or B will be less than or equal to B. A or B is also upper bound. B is also upper bound, but A or B is least upper bound. LUB means least. Least will be lesser, right? So A or B is less than or equal to B. This is equation number 1. Since A or B is upper bound, B will be always less than or equal to A or B. So this is from meaning of A or B. B will be always less than or equal to A or B because A or B is the upper bound. So now from equation 1 and 2, A or B less than or equal to B, B is less than or equal to A or B. Therefore, A or B is equal to B. So we know if A less than or equal to B and B less than or equal to A, then A is equal to B, right? Likewise, A or B less than or equal to B, B less than or equal to A or B means A or B is equal to B. Okay, therefore A or B is equal to B. Hence we have proved A or B equal to B if and only if A less than or equal to B. So first thing what you have to do is you have to take the first part and we have proved the second part, and in the converse part we have assumed the second part and we have proved the first part. Okay, for this we need the definition of upper bound. So A or B is upper bound means A or B will be less than or equal to B because it is least upper bound. But by definition B will be always less than or equal to A or B. So if you have these two conditions, we can replace inequality by equal sign. So A or B is equal to B here. Now similarly the second case also we are going to prove. Suppose A and B is equal to A. Okay, we are assuming this since by definition A and B is less than or equal to B. So this you have to identify. You see, A will be less than or equal to A or B. So but if you take and it will be like this. What is that? A and B will be less than or equal to B. Okay. And here because this is the lower bound, A and B is less than or equal to B. Now what is A and B by our assumption? A and B is equal to small a. Okay, A and B is small a. So you replace this A and B by small a. A is less than or equal to B. A is less than or equal to B. Therefore we have A less than or equal to B. Now conversely, if A is less than or equal to B, then we have to prove, okay, A is less than or equal to B, and we are going to prove the other case. A less than or equal to B and then A less than or equal to A. Small a is less than or equal to A because equal to condition is satisfied, right? So we take like also A is the lower bound of A and B. That means A and B is greatest lower bound of A and B. A is less than or equal to A is the lower bound of A and B, okay, because from the previous case A is less than B, A is less than A. So since A is lesser, A is the lower bound. A is the lower bound of A and B, okay, A is the lower bound of A and B. A and B is the, but A and B is the greatest lower bound. So A will be less than or equal to A and B. So from previous two equation, A is the lower bound. But we know that A and B is the greatest lower bound. Just now we defined meaning of A and B. You have to be thorough with that, okay? If you are thorough with the meaning of A and B, then you will understand this. A and B is the greatest lower bound. Greatest lower bound of A and B. So therefore this is greatest. This is greatest. Therefore A is less than or equal to A and B. Then since A and B is the lower bound, we know A and B stands for lower bound. That means A and B is lesser. A and B is less than or equal to A. Therefore from 3 and 4, A and B is equal to A. Hence we have proved both the cases, that is consistency law. 40. Let L less than or equal to be a lattice for ABC in L. B less than or equal to C implies A and B less than or equal to A and B. A or B less than equal to A or C. A and B less than or equal to A and C. A or B less than or equal to A or C. So we will consider this, okay. Second case is OR. That means AND can be replaced by star, OR can be replaced by plus circle. So anyway, it is enough you prove this. We will consider this one, okay, first case. And the proof we assume B less than or equal to C and we prove the RHS. Assume B less than or equal to C. So we know that by consistency law, A less than or equal to B means A and B equal to A or B is equal to B. So here B less than or equal to C means if you take AND, B and C is equal to the first term, B or C is equal to the second term. So this is by using this consistency law which we have learned now. If A less than or equal to B, we can write like this. Therefore B less than or equal to C, we can write like this, equation number 1. Now let us consider A and B and A and C. So we are considering, okay, just we are assuming, we are taking this, and you see all the operations are AND, all the conjunctions are AND. So taking A as common, A and B and C, we can write this as A and B and C. Now what is B and C? Now by equation 1, B and C is B. So we replace B and C by B. So we get B here. Now again we consider the same LHS by the definition of greatest lower bound. GLB means greatest lower bound. A and B and A and C, that is the same LHS. A and B and A and C is less than or equal to A and B. And A and B and A and C is less than or equal to A and C. That means you see there is a, I have written it here, A, B like that. Small a, small b and then small a. That means A and first term, second term. If you take and, that will be less than or equal to the first term. Similarly, first term and second term, this will be less than or equal to the second term. So just to understand, I have written A, B, A here, A, B, B here. Okay, that is not needed for examination. Just to understand, first two terms, if you take and, this will be less than or equal to the first term, that is A and B. Then this will be less than or equal to the second term, that is A and C. Now what about this LHS? From equation 1, A and B and A and C is equal to A and B. So now this LHS, A and B and A and C in both the equation can be replaced by A and B. So A and B is less than or equal to A and B. A and B is less than or equal to A and C. That's what we have written here using 2. Now what is our assumption from, we have started with B less than or equal to C. Is it right? B less than or equal to C implies, let me take this, A and B less than or equal to A and C. Now again we consider A or B or A or C. This is equal to A or, taking A as common, A or B or C. That is A or B or C. What is from equation 1? From equation 1, B or C is C. So we replace this B or C by C. So we get this. Again we take A or B or A or C. Okay, by definition, A or B less than or equal to A or B or A or C. A or C less than or equal to A or B or A or C. So this is by definition. That's why I have written here in small letter. That is, first term will be less than or equal to A or B. Similarly, second term will be less than or equal to A or B. So here you take A, here you take B. Okay. So this, just to understand, I have taken this one. So when you take OR operation, this we have learned in meaning of A or B. You can refer to meaning of A or B. A will be less than or equal to A or B. B will be less than or equal to A or B. That means here you see we take OR between these two terms. So first term is less than or equal to the next other two term. Similarly, second term will be less than or equal to A or B or A or C. Now what is A or B or A or C? Just now we have derived it, that is A or C. Therefore A or B less than or equal to A or C. A or C less than or equal to A or C. Therefore B less than or equal to C implies, so that's our assumption, right? So using this only we have proved A or B or A or C is A or C, right? So now we have got the conclusion, but we began with B less than or equal to C, right? B less than or equal to C. Our conclusion is, what's our conclusion? A or B less than or equal to A or C. Also A and B less than or equal to A and C. This already we have proved, right? This is the first case we proved. A and B less than or equal to A and C. So our question, we have proved both the cases. A and B less than or equal to A and C. Also A or B less than or equal to A or C. Hence, we have proved both the equation by assuming B is less than or equal to C. Okay.